We will study now quality of service. Okay, quality of service, or in short QOS. It is also important for the exam, semester exam. It comes in a short note of 5 marks. So let us see what is quality of service. So here we try to create an appropriate environment for the traffic. So in quality of service, we try to create an appropriate environment for the traffic. Okay. Now we will study about the flow characteristics. Flow characteristics. Okay. So first one, we will study about reliability. So what is reliability? Lack of reliability means that losing or acknowledgement. Okay. Lack of reliability, it means losing or acknowledgement. Next part, delay. That is source to destination delay. Next, so suppose source it is at 0 time we start sending, and for destination at 4 unit of time it reached, so the delay is 4. Okay. Next is jitter. It is very important. Jitter, that is variation in delay. It is nothing but variation in delay. Okay. So normally what is the variation in delay? Let us try to understand. Suppose there is a packet, the 4 frames. This packet contains of 4 frames. So let us say 0, 1, 2 and 3. Okay. So this is the source, and there is a destination. Suppose it goes to a destination at, this is the destination, at time is 4 and 5 and 6 and 7. So what is the delay you can find? All in cases 0 minus 4 is 4. This is 4, 4 and 4. That is the delay is constant over here. Okay. But somehow if we found that this 0 packet reaches at, suppose at 4, this 1 packet, this is as 6, this 2 packet, this is as suppose 10, and this is reaches as 12. So in that case, what will be the delay? So in first case, say source sent from 0 and it reached destination at 4, so delay is 4. Next it is 5, that is 6 minus 1 is 5. 10 minus 2 is suppose it is 8, and 12 minus 8 is 9. So we see that this is basically, this is a delay, and this is a variable delay. Okay. So this is called the jitter. Okay. So this is called the jitter. In this case, you see the delay is constant, that is 4. This is, in this case, this is delay is constant. 0, when say source sending at 0, destination reached as 4. So this is 4, delay is 4. This is also 4. This is also is 4. 6 minus 2, 4. 7 minus 4 is 3 is 4. But if the arrival of the packet in the destination is 4, 6, 10 and 12, we see that the 0 minus 4 is 4, this is 5, this is 8 and this is 9. So this differs. Okay. So this is called nothing but jitter. Okay. So jitter should be low. Now this jitter should be low for audio files and video files. Audio or video files. So we have to keep in this mind. Okay. So I hope you understand what is the meaning of jitter. Okay. Now we will study about some techniques to improve the quality of service. Techniques to improve quality of service. What are the techniques involved in the quality of service? First one is FIFO queuing, first in first out queuing. Okay, so we will draw like this way. So there is arrival. Okay, so if it is full, we will check whether it is full or not. Okay, so if it is full, that is if it is full, that is if it is yes, then discard. But if it is not full, then we will put in the queue. So these are all the queues. Okay, so we will put the packets in the queues, and from here there is a processor over there. Okay, so from queue they will go to the processor, and from processor there will be the departure of the packet. Okay, so this is the first in first out. So it will come and it will come over here. First packet, next packet will come. If it is not full, then it will go to the queue, and suppose it is full, then the rest of the packet will be discarded. So it is called FIFO queuing. But in case of FIFO queuing, we will also use another type of queuing, that is called priority queuing. So let us see what do you mean by priority queuing. That is, we will set the priority. Okay, so it is same as the arrival will be same. Okay, so arrival, it comes over here, and basically, so this is also like this way. It will check whether it is full or not. If it is yes, then discard. Okay, and there are many of like this queues are there. So these are all queues. So again it will, this is suppose 1 2 3, there are many queues are like there. So if it is yes, that is, if queue is full, then it is also discard, same as the previous one. There is a, now we will set some priority over here. So in this case, let us consider this is go to the low priority. So these are the low priority, and in this case this is suppose the low priority, this is the to some extent high priority, to some extent high priority, and this is suppose this is the most highest priority. That way we have defined the queues. Okay, so these are the, this is the high priority queue. Okay, so this will always come over here, and according, this is the processor, same, this is the processor. Okay, and this is the output, departure. Okay, it is the departure. Okay, now I think it is okay now. This is the departure. So this is the priority. So highest priority, for the, they will check for the highest priority, and according to the packet inside the queue of the highest priority, it will go to the processor and it will depart. And the low, and if the packet is for low priority, so it will come over here and it will stay, and when everything according to some after some time, the low priority will be served. Okay, but this situation will ultimately may cause some starvation, because we see that all time if there is something in the higher priority, then all time the value, the frames in the higher priority or the packets in the higher priority will get their first priority, and it will be processed. So this lower priority job, the lower priority packet will never be processed, so it may cause a starvation. So for the removing this problem, there are some we will go through another, that is another technique. So we will see that, that is weighted fair queuing. Okay, so we will see that weighted fair queuing. So let us go on seeing this. What is a weighted fair queuing? So in this case, in this case, so there is a priority queuing. In we have seen there is a problem called starvation. So priority queuing, a problem is starvation. What is the problem? Problem is starvation. Okay, and now we will study about how to remove this starvation. So we will go for weighted fair queuing. Weighted fair queuing. So what is a weighted fair queuing? In this case, the queues are weighted based on priority queues. Okay, so in this, the queues are weighted based on the priority queue. So let us draw the figure, and hope you will understand after drawing the figure. So let us draw this one first. Okay, this is arrival, and same thing, it will check whether it is full or not. If yes, then discard. Okay, and let us give this first queue as weight 3. So let us consider this as weight 3, weight equal to 3. Okay, so weight equal to 3 means that 3 packets from the queue, it will take the 3 packets from the queue and it will process. So 3 packet from queue and process them. Also there will be same thing, same as this one. If it is full, okay, if it is yes, then discard. Now this queue will contain, this will be weight of 2, weight equal to 2. So in this case, what will happen? 2 packets from the queue will be processed and discarded. And finally, there is another same full, whether it is yes, it will discard, and in this case only 1 packet will be processed. Though it is a priority, but still each and every time when the chance come here, it will process 3 times, and then it will process 2 times, and this will process on 1 time, and it will happen in the round robin fashion. Okay, and there will be a switch. So there will be a switch, and the switch will go on rotating in the round robin fashion. So when this one is when this switch is on, so it will take 3 packets, 1, 2, 3, and processed. When this, then it will go tilt over here and come over here. It will see that there is a 2 packet, so it is weight is 2, so it will take 2 packets and it will process, and then it will take 1 packet and it will process. So in this way, in the round robin fashion, if this entire thing will work, so we will see that there will be no chances of starvation. So this is switch. From there it will go to the processor, and then is depart. Okay, and this happens in round robin fashion. Okay, so this is about in round robin fashion. So what we have studied in the quality of service, that is in the quality of service, we understand what is the quality of service means, what are the flow characteristics, that is reliability, delay, and jitter. Okay, the jitter is very important, and jitter should be very low for audio and video files. Then how to improve the quality of service is very much important. So we will go first, we studied about FIFO queuing. Okay, next we studied about priority queuing, and see that in case of priority queuing there is a problem of starvation. Okay, because the highest priority queue will always be accessed, and lowest priority queue will never accessed. So to get rid of this problem, we study weighted fair queuing. So this is the weighted fair queuing, and see that each and everything is given weight. So when and it accessed in round robin fashion. So when each time, so every time at least every queue is processed. Okay, so in this way this starvation problem is resolved. Okay, and one thing I've forgotten about, there is another point of flow characteristics, that is reliability, delay, and jitter. There is another point that I should mention, that is the bandwidth. Okay, so fourth point of after jitter, that is at the flow characteristics of quality of service, that is the bandwidth. This point I have forgotten. So the bandwidth is nothing but different application queries. Okay, so it is nothing but different application queries. Okay, application requires. So different application requires different bandwidth. Okay, so this is all about the quality of service. It is important for semester exam. It carries 5 marks. So if you write full of those what I have studied, what we have discussed over here, hopefully you will get the full marks. Okay, thank you.